Okay, let's give you guys some practice now. So use change of variables to evaluate this double integral within this region. So press pause and have a go. Okay, so to do this, if we add x to both sides, that would be this thing here equals 3. Add x to both sides, y add x equals 6. You see, if we let u equals y plus x, then this thing here will become u equals 3, and this will become u equals 6. Nice and simple. So these two diagonal lines will simply become u equals 3, u equals 6. So those two diagonal lines will simply become u equals 3 and u equals 6. Nice and simple. Now if you go back to here, hang on. If you go back to here, looking at this, divide both sides by x. So y equals y over x equals 3. Divide by x, so that would be y over x equals 1. And then if you say let v equals this, then this will simply become v equals 3, and then this thing here will simply become v equals 1. So by making this transformation, this whole thing will simply become v equals 3 and v equals 1. V equals 3 and v equals 1. So it becomes nice and simple. So this whole thing here, notice that this is actually u. So we can put u into here. So this thing here will then become u. But when you make this substitution, you would need to make some sort of adjustment. We would need to work out our Jacobian. Okay, so we are currently here at the moment because working with this region, it would be working in terms of dv. dv means you're moving parallel to the v-axis. So you start at v equals 1, and then you move to v equals 3, and then you're scanning from 3 to 6. So in terms of u, you're scanning from 3 to 6. From 3 to 6. Well, we are currently here, but we still need to work out our Jacobian. So hang on. So we are currently here. We still need to work out our Jacobian. When you get to this stage, you have a choice of either working all in terms of u equals something and v equals something, or you can work in terms of x equals something and y equals something. You can eliminate it, but looking at this, we are not going to use this method because I don't really want to differentiate this with respect to v or u here. You see, if we work in terms of u and v, then the Jacobian is easier to work out. Well, you can use this method if you want. You can work all in terms of x and all in terms of y. If you use this method, then the Jacobian is simply you putting the absolute value of the Jacobian into here. But if you use this method, then you have to put 1 over the absolute value of the Jacobian. So just bear that in mind. Okay, so in this case, it's easier to use this rather than having to partially differentiate these two. Well, anyway, we are not going to use this method. We are going to use this method. So going this route, we now need to work out our Jacobian. So the Jacobian is differentiate u with respect to x. So differentiate u with respect to x. So that's simply 1. So this thing here will be 1. And then differentiate u with respect to y. Differentiate u with respect to y. That's simply 1. And then differentiate v with respect to x. So this thing here, when you differentiate it with respect to x, that will then give you this. And then differentiate v with respect to y. That's simply 1 over x. So the determinant would be this times this, take away this times this. So that will then give us this. Merge the two fractions together, that will then give us this. So the Jacobian is this thing here, but we will need to put 1 over the Jacobian. So hang on. So looking at the Jacobian, notice that this is u here. That is u, and then when you turn it upside down, it would be so hang on. Remember, we will need to put the reciprocal into here. So 1 over this thing here would be x squared over u. So we can put this into here. So that will then give us this. And then these two u's, they cancel each other out, giving you x squared, giving you just x squared. But then what is x squared? We would need to work in terms of u and v. We will need to work in terms of u and v. So we need to understand what x squared is. So looking at these two, let's eliminate y. So looking at this, times both sides by x, and then put this into the y here. That will then give us this thing here. So basically make x a subject now. So x equals this thing here. So x squared would be this whole thing squared. So we can put this whole thing into here. So that will then give us this thing here. Okay, so we are now currently at this stage. We are currently at this stage. So now, now looking at this, it's easier to integrate it with respect to u first. So I want to change these two around. Differentiating it with respect to v is slightly harder. So let's switch these two around. So switching these two around, that will then give us this. So now now integrate it with respect to u. So looking at this, integrate it with respect to u. So it's nice and simple. It's just to the power 3 divided by 3. So integrate it with respect to u. That will then give us this. And we're integrating from 3 to 6. From 3 to 6. So now we would put 6 into here, take away, put 3 into here. That will then give us this. Tidy this up. That will then give us this. So now we just need to integrate it with respect to v. So when you integrate this, it will become this thing here. Well, integrate this. That will then give you this, and then from 1 to 3. From 1 to 3, and then blah blah blah, your final answer is this. Okay.